how to resolve a rational function to partial fraction before integration. So we have a function there, the integral of 4x plus 5 dx dividing 2x plus 1 and 1 minus x. So we can see that the two brackets that we have here are two linear factors. Now in partial fraction we have different types, I think 3 types. So we have the linear factors, we have the repeated factors, and there's one last one that we have. But depending on the question given, it will determine which approach you should use. Now when you look at this one, it is a very simple function because we have a linear factor here, 2x plus 1, 1 minus x. And before we can integrate this, it is important that we resolve the equation into a partial fraction. Now let's see how we can go about this. Now partial fraction says that before we can solve this, we need to equate this equation to two constants. One will represent the first linear factor, then the other constant will represent the second linear factor. In case we have another bracket here, then the third constant will represent the third linear factor. Now when you look at this, the first constant should be a. We divide the result by 2x plus 1, then plus your second constant should be b. We divide the result by 1 minus x, which is here in the next bracket. Now we have been able to resolve this function into partial fraction. I need to bring the integral sign here, but because of the calculation, I'll avoid it, okay? When we finish calculating this, we will bring it back. Now the next thing we will do is that after we've been able to do this, we need to calculate for the value of a and the value of what? B. Once we are able to do that, it will be easy for us to integrate the function. Now the next step is we shall take LCM here. Now the LCM is 2x plus 1 times this one. So now we take our two brackets, 2x plus 1 multiplying 1 minus what? X. The next thing we'll do is to solve. Now these 2x plus 1 we have here, we'll cancel this one. We are left with 1 minus what? X. Use it to multiply a. So we have a here multiplying 1 minus what? X. Plus we have this 1 minus x here, which will cancel this. Whatever that you are seeing here simply means 1 minus x dividing 2x plus 1, 1 minus x. Now this will take care of this. So we are left with what? 2x plus 1. 2x plus 1 should multiply b. So I have here b into 2x plus what? 1. Now everything here should be equal to integral of 4x plus 5 dividing 2x plus 1, 1 minus what? X dx. Now watch very carefully. From here, we could see that the denominators here are the same. So according to the rule of partial fraction, we have to equate the numerators. So equating the numerators, what are we having? We have 4x plus 5 being equal to a into 1 minus x plus b into 2x plus 1. Now, how do we find the value of a and b? There are ways we can do this. I will use the cover up method for this equation because it's simple. Now, what this means is that when we cover here, we can work with a, and when we cover a, we can work with what? B. How do I eliminate either a or b to be able to find one of them? So let's start with what? B. Let us eliminate b. To do that, we pick the bracket multiplying b and equate it to 0. So we have when 2x plus 1 is equal to 0, we have what? 2x equal to negative 1. I use this to cross the sign. I have negative 1. We make x the subject, so x equals negative 1. dividing 2. So x equals 1 over 2. Okay? Now from here, this means that wherever we see x, we substitute negative 1 over 2. So the equation becomes 4 into negative 1 out of 2 plus 5, giving us a into 1 minus into bracket negative 1 out of 2. Let's close this bracket. Now, once I substitute negative 1 over 2 here, this whole function will become 0. Okay? So we have b into 2 and 1 over 2 plus 1. Okay? This cancels this. We have b into -1 plus 1, making the whole equation what? 0. So we have been able to eliminate b. Therefore, I don't need to write that. So now let's continue. Now these 2 can cancel this. We have 2 here. 2 will multiply. We have negative 2 plus 5, giving us. Now when this multiply this, we have a into 1 plus 1 over 2. Now when we punch this, we are getting what? 3 over 2. So therefore we have 3 equals 3 over 2a. So from here, we can multiply 3 by 2 times 2 here, which will cancel this, times 2. This time this, we have 6, giving us 3a. When I divide 3 by 3, I have over 3 over 3. This is therefore a equals 2. Do you get it now? Now, let's cover a and find the value of b. To do that, the bracket 1 minus x should be equal to 0. Now, we say that when 1 minus x equal to 0, what do we have? Then we have 1 equal to x. If I use the x to cross, I have 1 equal to x, which is the same as x equal to what? 1. So wherever we see x in the function we have here, let me label this equation 1. Wherever we see x in equation 1, we substitute 1. So when we replace x with 1, we have 4 into 1 plus 5 equals, and you know that we covered this place. When I substitute 1 here, the result is 0 for a. So we focus here. So we have b into 2, 1 plus 1. Now when we solve this, we have 9 giving us 3b. When we divide, we have b equals 9 over 3, which is equal to what? 3. So we see the value of a and b are 2 and 3. Now let's substitute the value of a and b here, giving us integral of 2 over 2x plus 1 plus 3 over 1 minus x. Okay, so from here, it will be easy for us to integrate this. Now what's something? I will use this integral sign to multiply this and this. Don't forget that the whole function is being multiplied by what? Dx, which we have here. So now we are going to have integral of 2 over 2x plus 1 dx plus the same integral 3 over 1 minus x dx. So at this point, let me show you a trick, and you have to listen very carefully. Now, when I look at the numerator, I have a value of 2. When I look at the denominator, I have 2x plus 1. The first question you need to ask yourself is, when I differentiate the denominator, will it be equal to the value at the numerator so that it will be able to cancel each other? Did you hear that question? Though we are doing integration, we still need to find out if we can differentiate this to make it the same as the numerator. Yes, that is possible, because when I differentiate 2x, the result is 2. When I differentiate 1, the result is 0. So now I have 2 at the denominator. This means that the integral of this function will give us the natural log of, or ln 2x plus 1, which is this, ln what? 2x plus 1. This is what the result will be. In the same way, let's go and check this side. You could see that when I differentiate 1, which is the constant here, the result is 0. When I differentiate x, the result is what? Negative 1, because there is a negative sign here. It is not the same as the numerator. Do you get it? So it will not be able to cancel the 3. So what I'll do is that I would have to factorize the 3 out, the constant at the top. When I do that, I'm going to have 1 dividing 1 minus x, so that the integral of that will give me the natural log of 1 minus x, which is ln 1 minus what? X, times the 3 that I factorized out. This time, I will not be able to cancel the 3. But here, I will be able to cancel these 2. When you get here, what you need to do is to say that let u, a certain variable u, be equal to 2x plus 1 for only this side of the equation. Now let us differentiate the u. So du with respect to dx should give me what? 2. Okay? Now when I get here, let us make dx the subject. Why? Because I have dx here in the main function. This side is over 1. When we cross multiply, we have du equal to 2 dx. 1 times du, dx times this. If I want to make dx the subject, divide through by what? 2. When we do that, what are we getting? We are going to get dx is giving us du over 2, which is the same as 1 over 2 du. It is very important that you always factorize the values out. So I have 1 here, which is at the numerator, and the denominator is 2. This is over 1. 1 times 2 will give me the same 2. Du times 1 will give me this function. So don't be confused. Now when we get here, we need to go back and rewrite the function in terms of the variable what? U. The reason why I didn't repeat this same step for this side is because even if I differentiate x, which I explained earlier, the result will not be equal to 3 to cancel this. So I don't need to do that. I just need to factorize the 3 out. So let's rewrite the equation. Now the equation becomes integral of 2 over, now here I said let u be equal to 2x plus 1. So I'll put u here. Then dx here represents what? 1 over 2 du. So I'll put it here. 1 out of 2 times du plus the integral of this side. 3 over 1 minus x dx. We will touch this one when we are integrating. So now from here, these 2 can cancel this. Now do you get it? And we are left with what? 1 over u. So the function becomes integral of 1 out of u du plus 3. Now watch, I am factorizing the 3 out. Integral of 1 over 1 minus x dx. So the integral of anything in the form 1 over a variable will give you the natural log of that variable. So this side, I'm getting what? The natural log ln u plus 3 ln 1 minus x plus k. K here is the constant of integration. So now what's something? From here, I said that let u be equal to 2x plus 1. So but u equals 2x plus 1. So when I rewrite this, I'm having ln 2x plus 1 plus 3 ln 1 minus x plus k. Note, it is not every day that it happens like this. When the function in the bracket is different, if this side is squared, okay, as soon as this side is squared, cubed, or changes, or there is a value multiplying, what I need to do is to apply the steps, because it will generate a certain value that I need to factorize to come and multiply the 3. Alright, so anytime you are solving something like this, you need to be careful. You need to know whether you should apply it or not. This is a very simple equation, so I don't need to apply. So the integral of 4x plus 5 dividing 2x plus 1 minus x dx is giving us the natural log ln 2x plus 1 plus 3 ln 1 minus x plus k, which is the constant of integration. So this is how you resolve a rational function into partial fraction before you integrate. And the only difficulty students have is when they get here. When you get here, you need to analyze the equation to know whether you are going to differentiate or not. If it is a simple denominator, it will be easy for you to integrate. You don't need to go through these steps. Also watch, you may come across various questions that will be here. You need to know, should I apply this or not? If you apply it, you get the correct answer. If you don't apply it, you might get it wrong. For here, I know what I am doing. That is why I didn't apply. So thank you very much for joining me. The name is Daniel and this is Tutor Think. I will take another example for this one and we call it a day.